and welcome to another statistics video. This one is going to focus on empirical rule. I learned that trick from another fellow statistics teacher, and I absolutely adore it because it really is this triumphant rule and trick that is seriously going to help you answer this essential question, which is how can I make predictions with models? So first thing we're going to start off with before we actually jump into the empirical rule is to look at some snowfall in upstate New York. So my sister gathered some data for us. Don't worry, she is in fact that bored over the record for the 2 seasons, and they are in inches. So the first task that I'm going to have you do is create a histogram for all of that data. So again, that's the one where it puts everything in a bin and looks at frequency. And then after that, you are going to look at the shape of the data, look at the center, the mean, and the spread, which is standard deviation. In case you don't remember, here's on a TI-84 calculator how to do a histogram, and more importantly, the windows is what I really want you to focus on. And again, scale, this one is the bin width. So I want your bins to be 2 wide. Go ahead and pause the video and try to create a histogram, and when you're ready, hit play. All right, welcome back. Hopefully your histogram looks something kind of like this. Again, amount of snow is on the bottom because I need to know what those numbers actually represent. And then your frequency, so how many days fall into the bins. For example, if I want to focus just on this one right here, the 4 to 6. So I would basically ask, okay, how many days had between 4 and 6 inches of snow? Well, that would be 1 to 3 days had between that much amount. So that's, again, how histograms can help answer the questions. To find the average and the standard deviation. In case you don't remember on a calculator, you're going to hit the stat button. Hopefully edit you use to put in your list, but then calculate is what you need to focus on. And specifically option number 1 is where all of that key information is going to be. And one variable stats, I promise, offers a statistician so many numbers because a lot of those you really don't want to do by hand. But again, that's one variable statistics where most of that's going to be found. And if you did in fact find it, you should have found 9 was the average, 4 inches, and the standard deviation was 2 inches. So all fine and dandy, not really all that fun. Here's where the predictions are going to kick in. Let's say I'm going to draw the average right here. So that's kind of that 50% marker, half and half-ish, give or take. So this is where you get to make some predictions. We're going to go up 2 inches. So 9 all the way up to 11 inches of snow. And we're going to go down 2 inches or 1 standard deviation to 7. So here's the question. What percent of the days got between 7 and 11 inches of snow? What should I expect? Is it, what kind of things like that? And then I could do this again. We're going to go up another 2 inches to 13 inches. And we're going to go down another standard deviation, 5 inches of snow. We're going to ask the same question. What percent of the days got between 5 inches and, let's go all the way over here, I know it's a little crooked, I'm sorry, and 13 inches of snow? What percent of the days got between that and that? And those are the questions that this empirical rule can answer. There is a rule that came up with it. Take a calculus class to figure out a little more. So if you go 1 standard deviation away from the mean, so up to 11 and then 7, that will give you about 68% of the data, going up 1 and down 1. So I'm going to do plus or minus 1 standard deviation from the mean. Notice we did this again. We went up plus or minus. Oh, there we go. Plus and minus deviation right there. So right here, plus or minus, we did 2 standard deviations. We went up to 13 and we went down to 5. Deviation should give you about 95%. So again, that means 95% of the days probably got between 5 and 13 inches of snow. And then if you got really excited and wanted to go up and down 3 standard deviations, you would get almost, but not quite 100% of the data. So again, notice this is kind of weird because if I try to go up 3 standard deviations, it's like, but wait a minute, you did get 100% of the data. So here's up and then down. That's because this rule applies to a bigger picture. It applies to this kind of a model right here. And this one has a name. You've probably heard it called a bell curve, but in statistics, we call it the normal model, is what it is. And it applies when you have data that is approximately symmetric and is unimodal. So it has that one big peak. Any data that has that, you can actually build a bell curve to make more approximations. So right here in the middle, we had 9 inches And then what I had you do is go up and down 1 standard deviation, or up 2 inches of snow. So there was 11. And we went down 2 inches of snow, which got us down to 7. And what we said is that was 68% of the data was between there and there. Not too shabby. So here's the good news. If you wanted to be right smack in the middle, well, that's probably 50% of the data, right? It's the middle, it's the average. And notice here, I made you kind of go the middle 68%. So if you want to, you can split that. So here's 34% and here's 34%. And then you can actually add that. So here's 84% is right here. And then you want to go down 34, so here's 16%. So still that middle 68%. Here's a fun little question. If you wanted to know what percent of days got 11 inches of snow or less, well, that would be 84%. So those are the kind of questions that you really get to start answering, which is kind of fun. And I actually made you go up more standard deviations than that. So I even made you go up another 2 inches of snow, so 13 inches of snow, and 5 inches of snow. And that one, 2 standard deviations, we said was 95% of the data. So 95% of the days should have gotten between 5 and 13 inches of snow. And you can do the same thing, kind of split that number into these 2 sections. If you do, hopefully you had a calculator, you should have gotten was 13.5 on both sides. So it's kind of fun to kind of estimate and use these percentages. And then again, you can kind of fill in these percentages right up here. So another 13.5, so that'd be 97.5 would be right here. So you could say 97.5% of the days got 13 inches or less. Same thing, hopefully you have down here, and this one gets in a little bit smaller because this is going to be 2.5. So you could say 2.5% of the days got 5 inches or less, because that's going this way. Not too bad. And notice there's this kind of information in the tails here, the kind of little itty bitty section. Well, in statistics, we call that section the unusual world. So anything between here and here. So there's the rest of that 100%. So here's 2.5 right here percent. That's what we call the unusual world. Those would be considered outliers. So anything that got more than what? 13 inches of snow would be unusual. So if a day had 15, 16, 20 inches of snow, that would probably shock the world. Like, whoa, that came out of nowhere. That was so unusual. That was so unlikely. Those kinds of things are what get answered in these unusual sections. But that's about past 2 standard deviations is what we consider, unusual. So, and if you really want to put those on here, you can. You can put 15 kind of over here on the edges, and you can go down 2 to give you 3. Not too bad. So what you've created here are called the percent, and you've probably heard this before, is a percentile. So when someone says you're in the 95th percentile, that means you're in the top 5%. And then usually you'll see that dealing with SAT and ACT scores is usually where I start to see them, but they kind of vary. Here's the fun news. These down here change with every single problem, because not every single problem deals with snow. And I'm going to put snow right here so you know what that means. And someone usually denotes it with a variable. I usually pick X because I'm the most comfortable. But this is the yellow line. This changes with every problem because, again, not every problem deals with snow. This is the fun part. If I'm stuck right here at the average, right here at 9 inches, I haven't really gone any standard deviations. So we put a 0. I'm stuck at the center. I'm nowhere above or below. Here, we went up 1 standard deviation. Here, we went down 1 standard deviation. So again, there's that 68 percentile. Here's 2 standard deviations up, and then 3 is all the way up here in the corner. We went down 2 standard deviations, and again, here's 3 in the corner. These lovely numbers also will match every single problem. If I go up 1 standard deviation, I'm in the 84th percentile. That does not change. That's what makes this model so amazing and so valuable to make predictions. And notice we can't really use the letter S because that stands for standard deviation. We saw that at the beginning of the note. So we need kind of another symbol or maybe another letter because that one is just not quite going to work. And in statistics, we use the letter Z. Specifically, these are called Z-scores or standard scores. And you'll see this a little bit later in another video, but the Z-scores will always match these percentiles. If I go up 2 Z-scores, 2 standard deviations, I'm at this percentile, and that will stay the same. It's just the bottom row. Very, very helpful. So let's try one quick example just to kind of see and get your feet a little bit more wet. So here's a normal model dealing with the birth weights. So I'm going to put birth weights. I need to always have a nice title because in statistics, we got to know what these numbers mean. And don't forget units. This one deals in pounds. Don't forget that. You'd be surprised how important that is. Well, this little box is probably going to be new to you. Draw a little box around this one right here. This little box we call the parameters because this is telling you the big picture for the population. So I can expect the birth weights of a population to be, and you can probably guess, is normal. Tells you what the shape of the data is. It's fairly symmetric with a mean right here of 7.6 pounds. And since this is the big picture, this is all the birth weights in the world, we can't use X bar because that's a sample. When you deal with population big world, you use this symbol. This means mu. Think Greek cow. It means the average. So here, 7.6. There's the center of all of my data. And you can probably guess what the 1.3 is. That is standard deviation for the population. This is called sigma, is what this symbol is. But that tells you it's all of the birth weights in the world, not just a tiny little sample. So I'm going to go up 1.3. This is going to give me 8.9. And I'm going to go down 1.3, which is going to give me 6.3. One standard deviation. I'm going to go up another. So here's going to be 10.2. I'm going to go down 1.3, so here's going to be 5 pounds, and so on and so forth. And you are more than welcome to label the data if you'd like. So again, here's the 68% of the data. You're always more than welcome to label those. And you can kind of label all the other ones. That one's pretty helpful, but I like to use the other one that we saw. So here was the 34%. I always like to do that. I think these numbers are a little bit more helpful. So 34% is between there and there. And then this was the 13.5 we saw right here. 13.5 was here. And then remember we said this was what we called unusual. Anything past here was 2.5%. Same thing here and here, 2.5%. There was where it got really fun, really unusual, really quick. Not too bad. So here's a statistics question. You said we have a baby that unfortunately was born prematurely and weighs 5 pounds. Well, 5 pounds right there. We want to know what percent of the babies weigh more than that amount. Well, here's the good news. That whole thing should be 100%, right? Kind of makes sense. I'm looking at 5 or more. Well, here's the good news. I know that is 2.5%, so I'm just going to take 100%, because that's everybody, and I'm going to take away the 2.5%, because I want weighs more, so anything beyond that. And voila, your answer of 97.5. So I can expect 97.5% of babies to weigh more than 5 pounds. Or my baby is in the 2.5 percentile. So very, very low, very born prematurely. And we'll just do one more question to help it stick. We want to know what percent of babies weigh between 5 and 6.3 pounds. Oh, that's pretty easy. Here's between 5 and 16.3. Oh, would you look at that? We've already labeled 13.5. Done. 13.5%. And there are so many questions that you can kind of continue answering, but that's at least, so there's a part C, but we're just going to do A and B for now because I think that'll help you see. Well, hope you enjoyed the empirical rule. Have fun making further predictions. Watch more videos to see where this model can really get fun. Thanks for joining.